And this we have caching, right? Distributed caching system. So first we have to know about what is caching, right? Caching is basically a high-speed data storage layer that store a subset of data. Typically, it is transient in nature, so that future requests that is asked by the client for that data are served up faster than the possible accessing the data's primary storage location. It allows you to basically reuse the previously retrieved or computed data. We have learned about caching. Now we will go through the what is distributed caching, right? So in caching, we have learned that it allows you to efficiently reuse previously retrieved data. In distributed, it is basically spread across multiple servers within a network to basically distribute it, right? So basically, it helps in enhancing the performance and scalability by reducing the primary data storage load, right? So it basically improves the responsiveness of the application by storing the frequently data access locations, right? And it basically used in reducing latency. Like it will reduce latency, then it will give faster response, right? And it will help. It helps in improving the overall system efficiency, right? So we will move forward to the defining requirement. In distributed cache, there are many kinds of nodes. Nodes 1, node 2, node 3 to node n, which are present in active and some may be present in passive instance, but mainly there are in active instance. There are two types of defining requirements, right? One is functional requirement and another is non-functional requirement. In functional requirement, we do have read data, right? In read data, we can quickly retrieve data from cache, right? And in write data, we store data into the cache, right? And there are eviction policies which are used, which we will read further, right? I will tell you in brief, right? It will automatically evict the things or cache by using the algorithms like frequently used, recently used, first in, first out. And after that, we have replication and function requirements. In replication, it is basically used to replicate the data across the multiple nodes for fault intolerance, right? Fault intolerance is basically resilience to node failures, right? So after that we have consistency. Consistency basically ensures the data is consistently across every node, right? And the most important is node management. Right? In node management, we can add, remove the cache node dynamically, right? Now we will go to the non-functional requirement. In non-functional requirement, we have performance, scalability, consistency, reliability, right? Durability and security, right? In defining requirement, we use basically in distributed caching system, we use use case diagram basically. Why we use use case diagram? Because use case diagram basically help us to visualize the interaction between user and the system, right? It basically visualize the interaction between the user and the client, right? In this, user can perform three actions: add, get, remove, right? Administrator can also use get three actions, and it can monitor the cache, and it can remove the cache, and it can add the cache, right? Client can use two. It can basically handle the cache hit or miss, or it can evict the cache data, right? And after that, we will move further to choosing a caching strategy, right? How we will choose a caching strategy? First, we have to choose the traffic estimate. What is the traffic estimate of the system, right? First, we will see there are two type of traffic estimate. First one is read traffic, and second one is write traffic, right? So first one in read traffic, we estimate the number of read requests per second, and in write traffic, we estimate the number of write requests per second. For example, if we expect 10,000 read per second and 1,000 write per second, our cache should handle this role, right? I'm using should because it is not necessary it will handle this role, right? After that, the second one is storage estimate. In storage estimate, we again is further divided into two types. it is basically data size and total data. In data size, it is basically the estimate of average data size of cache entry, right? And in total data, it calculates the total amount of data to be stored in the cache. For example, if we have 1 KB and we have 1 million entries, so the total storage required for this is at least 1 GB, right? So now after that we have bandwidth estimate, right? There is read bandwidth estimate that calculate the bandwidth needed for the read operation, and in write bandwidth we calculate the bandwidth needed for the write operation, right? For example, if each read operation is 1 KB, so we have 10,000 read per second, right? The read bandwidth will be 10 Mbps if we are taking just a lump sum example, right? We have taken the read bandwidth is 10 Mbps, so the time it will take is will be less, right? After that, it we are using memory estimate, right? Memory estimate, in this there are node memory that estimate the amount of memory required per node, right? And after that, there is uh, data partitioning. Data partitioning is basically how is data partitioned, like it is split into smaller chunks, like the client is divided into cache, and cache is divided into node 1, node 2, to node and data source and monitoring services. What is client? Client is basically is any application that interact with the cache system to perform read write operation, and client can send requests to the cache to retrieve or update data, right? uh, this is basically we can use what we can say, like we can use it is responsible for handling read and write operations in nodes. What is nodes? Nodes are basically it is basically individual servers or active instance that store the cache data, right? Each node is responsible for a portion of overall cache that handle read write operation, right? And we have monitoring services that check the health of the cache system. It collect the metrics such as cache hit, cache mesh, and node health status, right? It basically ensure the system operate efficiently and to identify and resolve any issue that is been that going to occur or can issue promptly, right? And after it we have cache eviction. And in cache eviction, we have policies or algorithm we can say that is used to determine which data to remove from cache when it is pulled, aiming to optimize its performance. Right? Common strategies we have used, I have right here: LRU, LFU. Right? In LRU, LRU is basically the full form stand for least recently used, and LFU stand for least frequently used, and TTL is used for time to live, right? And least recently used, we use basically maintain a timestamp for each item last access. When the cache is full, when the cache is full, the item with the oldest timestamp with will be erected. In least frequently used, that it tracks the access of frequency of each item, and when the cache is full, the item with the lowest access of frequency will be evicted, right? And in time to live, there are basically the item will be removed based on the expiration time and ensuring the data freshness, right? And after that, we have load balancing. In load balancing, basically it is a process of distributing incoming network, like which has been incoming network, or the workload across multiple servers, or the we can say or resources to optimize utilization, right? It basically used for enhancing the performance and ensure high availability by preventing any single server from being overloaded, right? It's basically used for improved performance, enhance scalability, increase availability, and resource optimization, right? It basically use round robin method that distributed requests sequentially each server in a pool, right? Or we can say weighted round robin with distributed traffic based on the server capacity or performance. Next we have monitoring uh, and metrics, right? Matrices. It is basically plays a crucial role in building a system, right? It basically understand the performance and health of the system and enabling the identification of the bottleneck and optimization opportunity that can increase the cache hit ratio or latency, throughput, or memory usage. Right? It is basically used for performance optimization, capacity planning, and troubleshooting. Troubleshooting is basically uh, a root cause problem such as cache miss, so network issues, server overload, and scalability. Last, uh, it basically in this we have I told you about throughput, right? Throughput is basically the number of requests the cache can handle per second. It is called throughput, right? After that, we have security. At last, in security, we basically security plays a very crucial role in everyone's life. So in distributed system, we'll talk about distributed system. It basically ensures the data integrity, confidentiality, and availability across interconnected networks. Like with key measures, including implementing strong authentication measures. Like it is written in the first point, authentication. Like we can say strong authentication with an example of MFA, multi-factor authentication, or we can say RBAC. RBAC should be a new term for you. Robust authorization control, such as it is based on role-based access control, which is then a part of authorization, right? It is basically in secure system security, the practice of protecting information system from unauthorized access, modification, or destruction, right? It is basically a concern because there are many threats like DOS attacks, right? Or DOS basically denial of service, right? And man in the middle attack and eavesdropping, right? Can disrupt, can basically disrupt or destroy the functioning of the distributed system, right? So we can we will have to in this system we are heavily relied on the communication between nodes, and these network become a potential point of attack. So we use the MFA and RBAC protocols. Okay, thank you.